Good morning.
Good morning.
So, how's everyone today?
Good.
Anything exciting going on?
Winslow's having testing for their underclassmen
Oh,
this whole week.
aren't you? But that doesn't involve you, though, right?
No, not the seniors.
Oh, how wonderful that you're in this class, right? So, because is it the AZ Merit? Or
Yeah, it is.
so it only goes through like Algebra 2 classes, is that right?
Yeah.
Okay, awesome. Yeah, I always liked it when for my pre-calculus and calculus students that we never had to fool with any of that nonsense. So anyway, good for you guys. Way to be, Winslow. So is everybody there in Winslow today?
Not Alana.
Not Alana. Okay. All right. Let's see. So who we got missing in Joseph City?
I'm the only one today.
Okay.
Auburn's here.
Oh, Auburn is there? Okay. And how about
Toby's gone today.
Toby? Okay. I learned his name is Rex, and so I have to think of another. Okay, now what's his other name? All right, Holbrook, we're all there. Ellie's closing night as the star of Addams Family. So that's pretty cool. Anything else going on? All right. So, let's see. So today we're going to hopefully finish 9-1 and then maybe go into 9-2. That's kind of the plan. Anyone have any questions, comments, concerns before we get started with today's lesson?
Are you putting a curve on the midterm?
Oh, I totally forgot. I totally forgot to do that. All right, so let me, I'll make a note of that right now. Yes, I'm doing a curve. And let's see, I decided to do 10 points instead of 8. But I totally forgot to adjust those scores. So let me write that down. Thank you for, golly, midterm curves. Okay. All right. Yeah, I told you I was going to do that and totally spaced that off. So sorry. But yeah, so I just go in and I physically change your score. So like if it comes up as a 78, then I'll change it to an 88 or whatever. Okay. All right. So okay, so I have that we were on practice 2B, and I had asked that you guys try your hand at sketching one of these ellipses. Okay, so let's take a look at that one. All right. So anyone have any trouble with seeing the board, or everything's okay? Visually, we're all good? Okay. All right, so it says to sketch the graph. So the first thing you do when you're trying to sketch the graph of one of these things is to find the center. All right, so what would the center be? Just anybody, call it out.
-2, 1.
-2, 1. Excellent. So you change the signs of these numbers. So that's the point you go to first. So from the center, then you'll go left and right, how much? Or how far?
Left 2 up 1.
Left 2 and right 2. And then up and down, how far?
1.
No?
Oh,
3?
3. So it's the square root of these numbers. Okay. So you go to the center at -2, 1, and then you'll go left and right 2, and then up and down 3, and then you connect those dots in an elliptical fashion. Now, it doesn't ask you to find all these points, but you could, just counting or whatever. Now, it is a vertical ellipse because this number is bigger, the number underneath the y. Okay. All right. Anyone have any problems with that? Any questions?
Mr. Strong,
Yes?
I just want to let you know Alana came in.
Oh, okay. Thank you. Thank you. All right. Anything else? Okay. Okay, so now what we want to do is this isn't on your sheet. This is just kind of a little matching activity because I could easily do something like this on a quiz. So where I give you the equations and then the ellipses, and then we want to match them. Okay, so this is just a matching exercise. All right. So let's start with, who do we want to pick today? All right, so Dominic. All right, so let's have you do for A, equation A, which of these ellipses would be the graph for equation A here?
3.
All right, so let's see. So the center here would be -2, 0. And you go left and right 1 and up and down 2. So that's it. So here we'll just draw a line here from A to 3. Okay. All right. So now the next one. So B, let's have Junior. So which one of these would be for equation B?
1.
1? All right, let's see. So the center is -2, 0. So -2, 0. We go left and right 2, up and down 3. All right, great job. So B would go here. And so then C would be here. The center would be at, oh, wait. Wait, what's going on here? Yeah, let's see. Two, 0. Oh, yeah, so it would be right here. So the center is at 2, 0. We go left and right 2 and up and down 3. So that's going to do it. Okay, any questions on those? Great job, everyone. Okay. All right, now, when putting an ellipse in standard form, remember that the equation must equal 1. Okay? Must equal 1. So if it's not equal to 1, then it's not going to be in standard form. All right, so let's just say we had like a 36 over here. So then to make this 36 equal to 1, what would we divide by?
36.
36, okay? Because 36 divided by 36 is 1, okay? And so then now the 4 over 36 will simplify to 1 over 9. And so then now this is in standard form, and then you could go ahead and graph it, okay? So if you have a number over there, okay, but what if you have like this mess here? How would you put that into standard form?
Subtract the 9 and then divide by 9.
Okay, subtract the 9 and divide by 9, but what about all this other stuff? How are we going to get that in standard form? So I'll give you a hint. We did one similar to this in working with circles back in last semester. So anyone remember what we had to do there to put the circles in standard form? Well, what we have, go ahead, Ellie, you're going to say something?
Would you like put the y's and the x's together and factor?
Okay, you put the y's and x's together and not factor.
But like simplify?
No, what we're going to do is complete the square. Complete the square. Because remember that for the center, you got to have x minus something squared and y minus something squared. You have to have those be perfect squares. But so what we're going to do is get the x's together, get the y's together, and then the 9, we're going to just move it to the other side for now. Okay? All right, so now what we do is, okay, so we have x squared plus 6x plus something we're going to add to make that a perfect square. And then 4y squared minus 8y plus something to complete the square. And then the 9, we move to the other side. Now, before we complete the square here, though, we want to factor out that 4. Okay? So it's going to become y squared minus 2y. Okay? Now, let's see, do you remember what do you add to complete the square? What number are we going to add in this first parentheses?
1.
Nope. We're going to add 1 in the second one.
2.
How about in the first one?
Is it 3?
Okay, you're on the right track. You take half of the 6 is 3, and then square it. That's
So
what you
9.
add. Okay, so 9. So we're going to add 9 over here, and so we add 9 over here to compensate for that. And then we add, so half of negative 2 is negative 1. When we square that, we get 1. But really, we didn't add.
Did he just like go away for you guys too?
Yeah, he just went out.
Okay.
Chicken doesn't work out here.
All right, we're back. We had a power surge here at MPC. And so, yeah, so I guess you guys weren't, none of you were affected, but anyway, we had the whole building go dark here. Anyway, so we'll get back to it. All right. Oh, we were putting stuff in standard form. Okay. Let's get back. Okay. So we were. Oh, we can't see it. Okay. There we go. All right. So we were right here putting stuff in standard form. And so we said we were adding a 9 here. So if we add a 9 to one side, we have to add a 9 to the other side. Okay? And then here, we actually, when we put a 1 here, because we factored out a 4, we actually are adding a 4, so we have to add a 4 to this side. All right, so now we say, all right, well, this is x plus 3 quantity squared. And this is 4 times y minus 1 quantity squared. And then the 9's will cancel. 4 times 1 is 4. Okay. Now it's kind of like the last example that I did where everything is all right except we don't want a 4 over here. We want a 1. So we're going to divide everything by 4. And then we'll get our ellipse in standard form. So x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. Okay? All right. So any questions on that? Okay, why don't you go ahead and try practice 2C. We're good. Thank you. Okay, so Ellie, when you've got it or if you get stuck, let me know.
Alright, so I got completing the square part, but after I take the 9 out of the parenthesis and the 4 out of the parenthesis, I don't know what to do with that. So kind of got stuck.
All right, so to there?
Yeah.
Okay, so now you have to think, well, what is it that you add? And so it's the b divided by 2 squared. So that's what I've written down here, b divided by 2 squared. So 4 divided by 2 is 2, 2 squared is 4. So you put a 4 there, but you've really added a 36, so you have to put a plus 36 over here. And then here you're going to add, half of negative 2 is negative 1, squared is 1. So you put a 1 here, but you really have to put a plus 4 over on the other side. Okay. So now you have to say what the perfect squares are. So this is the perfect square of what?
So it'd be the x plus 2 squared.
And this one?
Y minus 1 squared.
Good. And then finally, you divide by 36. So whatever this number is over here, you divide by 30. You divide by it. So divided by 36. And then the 36 will cancel with the 9, and it cancels with the 4. And so then that's your final answer.
Okay, so you just leave like the 9 and the 4 in front until you're ready to divide.
Until you're ready to divide, and then it'll go away.
Okay.
All right, and so then finally to graph it, you say the center is negative 2, 1. So negative 2, 1. And then from the center, you go left and right 2, up and down 3, and then boom, there's your ellipse. All right, any questions on that one? Okay. That's probably the hardest type in this section. Okay, so in order to construct the standard form equation of the ellipse, we need 4 pieces of information. So the center, and then either the major axis or the vertices, and then the minor axis and the foci. Now, sometimes we don't have to have all 4. Maybe we only need 3 of the 4. But these are usually things that we're given and then asked to graph it or put it in standard form or something like that. Okay. All right, so this one says to write the equation of the ellipse. So, so we're given the graph, and we have to come up with the equation. So the first thing I do in these is figure out the center. So if the center here is 0, 0, then that means that the top is going to be x squared plus y squared equals 1. So then I look and say, well, in the x direction, I go to the left and to the right 2. So 2 squared, or 4, is going to go underneath the x. And then in the y direction, I go up and down 3. So 3 squared, or 9. Wait, I counted wrong. 1, 2, 3, 4. So 16 would go underneath the y squared. And so that's that. That's the answer. Okay. All right. So go ahead and try practice 2D. All right, so Andrew, when you've got it.
Unmuted. Oh. I got x squared minus 2. Y squared minus 1 equals 1.
Okay, so you have x squared minus 2 or x minus 2 squared?
Ooh. X squared minus 2.
Okay. Let's see, did I? Oh. No, okay. Okay, so here, see, it's got to be, so the center is at 2, 0, or 2, 1, excuse me. So then it's going to be x minus 2 squared. Plus, and then what about the y part? What will that be?
Y. Wait. Y minus 1 squared.
Good. Y minus 1 squared. Okay. And then equal 1. All right. And then what number is going to go underneath the x squared?
9.
9. And what number underneath the y?
1.
1. Or actually, if you didn't even have anything, it's assumed to be 1. So that's good. All right. Any questions on that? All right. Great job. Okay. So the last little part, I can find it. Okay, is what's called the eccentricity of the ellipse. Okay. Now, the eccentricity, if kind of informally, is like the ovalness of the ellipse. Okay. So, like, if you have an eccentricity of 0, then that's a perfect circle. And an eccentricity that is closer and closer to 1, it gets flatter and flatter. Okay, it becomes more and more oval and less circular. Okay, so the formula for finding the eccentricity is E equals C divided by A. So where C is, to the distance to the focus, and A is the biggest one of the numbers, the square root of the numbers underneath. Okay. All right. So let's we're actually going to use eccentricity later in another section, and so it's this is kind of good to give us a little bit of some practice with it. Okay, so let's say we want to find the eccentricity for this ellipse. Okay, then what we're going to do is we're going to find C. So C squared is A squared minus B squared. So 36 minus, well, there's no number there, so it's assumed to be 1. So C squared is 35, and we use the positive square root in this formula. So it's square root of 35, and then the A is the square root of the bigger of these numbers. So the square root of 36 is 6. So the square root of 35 divided by 6, which is actually pretty close to 1. So when your E is close to 1, then that means it's going to be really flat. But it is an ellipse. Okay? It is an ellipse, and it's going to be pretty flat. All right? So see if you can do practice 3. So the last practice problem there on your sheet. Okay. All right, Caden. What do you have for E? You can give it to me as a fraction or a decimal.
I didn't really understand how to do it.
Okay, so do you remember how to find C? Okay, so the formula for the ellipse is C squared. Here, let me write that down again. So C squared equals A squared minus B squared. So these two numbers down here are the A squared and the B squared. So you just subtract the biggest one minus the smallest one. So 49 minus 4. And so you'll get C squared is radical 45. So C is the square root of 45. Okay. Now, the A is the bigger of these two, the square root. So this one is A squared. So that means A is 7, because 7 squared is 49. So then to find E, that would be the C divided by A. So the radical 45 over 7, which I would want you to simplify that or just put it in your calculator and get a decimal. All right, so Caden, go ahead and put that in the calculator and tell me what the decimal is. Square root of 45 divided by 7.
0.958.
Okay, so 0.958. Great. So anytime you see an eccentricity that's close to 1, then that means it's going to be very oval. If it has a small one, like say 0.2 or something like that, then it's going to be very circular. Okay. All right. Any questions on that? Okay, so that's it for 9.1. So I want to go ahead and start on 9.2 here today. We're not going to get as far as I'd hoped because of the crazy power. Okay. Also, if any of you remember, I had said that I was going to open up the stuff from chapter 8 for the quizzes. So a couple of you had reminded me about that. So those should be open. So let me know if you have any trouble with those, any of those quizzes. Okay, so now we're going to go on to parabolas. Now, this lesson in parabolas is kind of interesting because we actually did a section on parabolas in Math 152, but the focus is going to be a little different. It's now that we're going to teach it with the other conics, we're going to look at things like the focus and the eccentricity and that kind of thing with parabolas. Okay, so we're going to talk about the standard form of a parabola and then an application with parabolas. Okay, so just to kind of, so one of the things that's different here is that we just have one focus. And so the parabola, we're used to it going up. Well, we have a focus and a directrix. And the distance between the focus, which is the point in the middle, and the directrix, which is a line outside the parabola, that distance is always the same. Okay. Now, we also use the vertex, and then the distance between the vertex and the focus we call P. And that is always the same. So P is not a variable here. Well, I mean, it is, but P represents that distance. Okay. So we'll go into that in more detail. All right. So we mentioned all of the conic sections. And so we did the circle, like I said, in 152. We've done the ellipse. And so the parabola is formed when a plane intersects one of the bases of one of the cones. And that forms the parabola. And so that's what we're working on in this section. All right. Now, let's see. So circles, let's go through that. Let's see. Okay, we're not. Okay, so this first part is if we were going to go through the circle, and I'm not. Okay, so this part of parabolas, parabolas are in arches, or like here the supports of a bridge. Have the cables form a parabola. Okay. And so we've already learned that parabolas in this form, but now we're going to kind of use it in relation to the other conic sections. So we're going to define a parabola as the set of all points x, y that are equidistant from a fixed line and a fixed point. So, just like the circle was the set of all points that were same distance from a center, now we're saying the parabola is the set of all points that have the same distance from a point and a line. So the point we call the focus, and the line we call the directrix. So when we studied parabolas before, we didn't use either of those. Okay. So the midpoint between the focus and the directrix is the vertex. So that vertex, that's exactly halfway between the focus and the directrix. So that vertex is a super important point that we have to find. And then the line passing through the vertex is called the axis. So here's the axis, and so the axis goes through the focus and the vertex, and then intersects with the directrix. So that's the axis, or the axis of symmetry. I actually like the name axis of symmetry because you see that one side of the parabola is symmetric to the other. But sometimes they'll just call it the axis. Okay. All right, now. Okay, so the standard form. Well, before we studied like the vertex form of the parabola, but now we're going to have these four here are going to be the standard form. So it depends on which is squared. Because you'll either have x squared or y squared, but not both. Okay, so if you have a vertical set of axes, so that means the parabola opens up or down, then this is the standard form. the x is squared. So it's x minus h squared equals 4p times y minus k. If the axis is horizontal, then that means it'll open up either left or right. And so its standard form is y minus k squared equals 4p times x minus h. Now, in both cases, whichever way it goes, the vertex is at hk. Okay, the focus lies on the axis p units, and that's what we call a directed distance. So that means if it's positive, it goes up, negative down, or positive right, negative left. And then finally, the last two blanks in that first column are these two equations. If the vertex is at the origin, then see there's no h and k. So h and k both go away, and so you just get x squared equals 4py and y squared equals 4px. Okay, any questions on that? Does anybody need any more time on that slide?
Yeah.
Okay. Okay, so what I'm going to do is I'm going to go through an example, and the practice 1A I would like you to do before class tomorrow. Okay, so let's go through the different steps. All right, so let's see here. No. All right. So here, let's say I have this, and I want to know what is the vertex. So to find the h and the k, you take the opposite of these numbers again, just like we did with the ellipse. And so the vertex is going to be positive 2, negative 1. Now, since the x is squared, then that means it's going to be a vertical opening. So it's going to open up or down. All right? Now, and actually, well, then the next thing we want to do is find p. So the number in front here, you set that equal to 4p. So 4p equals 4, so that means p is equal to 1. You just solve it for p. Now, so this tells you how to find the focus from the vertex. So if you have the vertex and p is positive, you go up. If p is negative, you go down. So here, this is saying the vertex is up 1 unit from this. Okay? So if you graph your point, your vertex at 2, negative 1, and then your focus you go up 1. Okay? So if the focus is up 1, then the directrix is down 1, because this distance is always the same. So that would go through the line y equals negative 2. So that would be the directrix. Okay? So once you get p, that helps you find the focus and the directrix. Okay, as well as kind of give you an idea of the graph. Okay, so first you find the vertex, then you find P, and then P tells you from the vertex how to get to the focus, and then you go in the opposite